Lesson 53, numerical integration of positive valued functions on a graphing calculator. Thus, have a calculator with you. Recall the following. Find the derivative of f of x equals 5x minus 1 to the third when x equals 1 on a graphing calculator. So, what do we remember about finding the derivative on a graphing calculator?
Alpha window, inderivative. But right under inderivative, there's an FN8, which I assume we'll use.
Okay. I heard Ross said something about alpha.
Alpha window.
Okay, so he's at alpha F2. I always think the math window, or the math button, which math is right under alpha, and then I go to math 8, is what I say it as, just because not everyone has the alpha shortcuts. Always. Okay, and you remember you just kind of fill it in, right? So I'm going to write up here in case you forget. It's math menu number 8. And when you're filling that in on the calculator, you're filling in what? It's d over dx of what goes in your parenthesis? The function, so 5x minus 1, quantity cubed. And then you have that evaluation bar. And then it's going to be x equals 1. That sounds familiar, right? Make sure you remember how this works. Did I type that right? Yep. 5x minus 1 cubed, x equals 1. Your answer should match my answer. So f prime of 1 is 240 point. Well, officially we need 3 decimals minimum. 4 decimals is AP, or is the Saxon book. I'm just going to write the whole thing, I think, for right now, but 240.000125, which, according to AP Calc, would just be 240.000, so 240. According to the Saxon book, they'd put the 1 on there. Okay, this sounds familiar, right? Well, notice, today is integrals on the calculator. And I think it was kind of already noted that there's something right below on the calculator. So we can do the same types of problems with integrals or antiderivatives. Again, just like derivatives, it only works if you have a value to plug in. With integrals, it only works with definite intervals. It doesn't work if you don't have a value to plug in. So, example 1. Use a graphing calculator to approximate the integral from 2 to 3 of x plus 7 dx. Well, if you hadn't already figured it out, I'm going to say that this is math menu number 9. Now, I think everyone's calculators, we should be able to enter it the same. Did you guys enter it and get an answer already? So if I go math 9, which is FNINT, that is your integral function. Notice it brings up an integral. You're just filling in the pieces. So fill in your 2, fill in your 3, fill in your function, and d, fill in what variable that we are integrating with respect to, dx. Does your answer match my answer? I thought you were telling me no at first. Now, I do want to use this space kind of as a proof. I want to work this by hand. It's an easy one to work by hand, right? I want to work this by hand just to kind of show you that it does work. I will say, you guys all have the TI-84s, don't you? This type in F in int x plus 7, comma x, comma 2, comma 3. That is for the TI-83s, I think. You have to use a total different format. Okay, they don't give you the nice math font, derivative, and all of that. So you guys don't need to worry about that. Will you work this with me by hand, please? Oh, well, thank you. So if we're going to check this by hand, I'm doing the integral from 2 to 3 of x plus 7 dx. Hey, it's always good to do a little bit of calculus by hand sometimes to make sure we know what we're doing. Okay. Huh? Enriches the soul. Ooh, good phrasing. Okay, what's the integral of x? Okay, 1/2 x squared, or x squared divided by 2 if you please. Integral of 7? 7x. And then we're going to say evaluated from 2 to 3. And officially, I can't really just use the evaluation bars here. I need to use the square brackets because the evaluation bars really only work if it's just one term. And I want to include all the terms. We start by what? Plugging in 3. So 1/2 times 3 squared plus 7 times 3. I'm going to put that value in parentheses. And then minus, I'm going to set another set of parentheses. This time it's 1/2 times 2 squared plus 7 times 2. Okay. Well, half of 3 squared, 9 halves, 4.5, plus 21. 21 plus 4.5 is 25.5 is what my brain is saying. Half of 2 squared, so half of 4 is 2, plus 14 is 16. 25.5 minus 16 just so happens to be 9.5. Yeah. Okay, so forcing you to do a little bit of by hand integration there, just to kind of review. But are there times you can use a calculator? There are. Okay. I don't want you to get into the habit of always using the calculator, because are there times you still have to integrate by hand? There are. Okay. And what it comes down to, multiple choice on the calc test. I mean, there's so many you have a calculator for, there's so many you don't have a calculator for. With that in mind, they would never have this on the calculator section. Way too easy. This is definitely a work it out by hand, non-calculator type problem. Okay. Now, when it comes to the free response, open-ended type questions, could this be within a bigger problem? Definitely. Okay, they could easily have this on the non-calculator section. They could have this within something on a calculator section. And here's the nice part. If you're on a free response problem and they give you this, or you decide, not that they would give this to you, but you decide this is the integral we need to evaluate, and you're allowed to use a calculator, obviously the AP graders know when you can use a calculator. They know if you have access to a calculator on that problem. You don't have to show the work here, because they know you can use a calculator. You could just put that right there. You could just randomly come up with a 9.5 and throw a 9.5 in your problem. But if you write out the integral of 2 to 3 x plus 7 dx as, okay, that's what I need to do, and then you just magically say it equals 9.5, they're okay with that because they know you're allowed to use a calculator. Okay? To be honest, it probably wouldn't be that easy of a one to use a calculator on, but, you know.
At least make you do some work typing it in.
Yeah.
Throw a few exponents in there or something.
Yeah. The ones you'd see more on the calculator would be the ones that you can't easily do by hand. That's what you're more likely to see. So, okay, obviously you guys probably don't have questions on this. Okay, it is a calculator, so it's doing specifically just the integral. Okay, yes, integral is area under a curve, and that's going to lead us into the next problem. Using a graphing calculator, approximate the area under the curve of y equals sine x between x equals 0 and x equals pi over 6. Is that bad? You have to throw things back there? Okay, so first of all, it's telling us using a graphing calculator. It does say to approximate. If they want an exact answer on this one, we couldn't do an exact answer because we're going to get a decimal. So, and it's area, right? So what is it I'm going to be finding? The integral. You have to be able to set it up. You can't just give me an answer. Integral what?
Should be integral. We would have 0 on bottom, pi over 6 on top of sine x.
Okay, the integral from 0 to pi over 6 of sine x dx. As long as you write that, yes, you can just throw that into your calculator and you're good to go. That looks weird. You guys got a calculator answer for me?
I got 0.1340.
Are we getting the same answer for those of us trying it? Okay. 0.1340. And is that an approximate answer?
Yes.
It is, isn't it? It's an approximate answer. It's a decimal. And it's a decimal you had to round, correct? So that is definitely an approximate answer. Now, if you think about the sine curve, can you visualize the sine curve from 0 to pi over 6? It's all above the x-axis, isn't it? Because, I mean, our sine curve, if you want, is that right there, isn't it? So, and this is 0, this is pi, so 0 to pi over 6 is like that little tiny piece right there, isn't it? And I probably even really made that too big, but that's the area under the curve. You will notice today it says numerical integration of positive valued functions. When your curve goes below the x-axis, we're going to have to compensate for that by hand. You can't just go straight to the calculator. But I think that comes up later on. Now, can we practice this exact for a moment? Because this is something you guys could really probably benefit from practicing exact. Yeah, we're going to. Yeah. I'm just going based on the mistakes you guys make on tests, which there wasn't anything necessarily like with this one that affected your last test. But previous tests, this is a place mistakes happen with the trig stuff. So, what is the integral of sine? Okay, we know it's some kind of cosine, right? And this is where I say, okay, if I'm doing the derivative of cosine is not sine, is it? It's negative sine. And so that's where I have to know I'm going to do negative. So it's negative cosine x evaluated from 0 to pi over 6. So what's that mean we're doing? Negative cosine of pi over 6 minus negative cosine of 0. Now, we're not going for the calculator answer here. We're going for the exact answer here. We'll compare at the end. So, cosine of pi over 6.
Let me draw my triangle.
Yeah, let me get the triangle.
So you guys go for the triangles. I go for the charts.
Yeah,
I go over here and I go, okay, we've got the sine column, the cosine column. And this right here is why I'm suggesting, should we try this one by hand real quick? Pi over 6, pi over 4, pi over 3. I go 1/2 in the first one and 1/2 over here. I know my middle row is square root of 2 over square root of 2. And these other two are square root of 3 over 2. So, what's the cosine of pi over 6? Square root of 3 over 2. We officially want the negative cosine of pi over 6, so it's the negative square root of 3 over 2. minus negative, so I'm going to say plus, cosine of 0. And I don't know, I think a lot of you guys go the quadrants, don't you? But again, I like to, if you can visualize a cosine graph, here's 0, right? What's the cosine of 0? It's 1. How can I check this answer and see if it matches? Can we try this on the calculator? Okay, so the idea, let me go back and do my integral real quick. Math 9, so it's the integral from 0 to pi divided by 6 of sine x dx. I have that 0.1339745,962. If I want to check that to see if that matches my approximate, well, it was what? Negative square root of 3, oops, divided by 2, and then plus 1. Notice? My answers match, right? So, again, difference between approximate and exact. Approximate can be around a decimal. Exact is exact. That would give me the full answer. Okay. This is why I said bring your books, because that's the lesson.
Yes, we do.
Okay? It is a short lesson.